Testing, testing. Ooh, excellent. Hello, everybody. All ready? All right. Well, so this is going to be, oh, you're not going to work. Yeah, it does work. Excellent. Technology. Alrighty, so this is going to be just a sort of overview on what goes into making a modern desktop Linux laptop work. So a quick introduction. Mark Pearson. I work for Lenovo, technical lead for the Lenovo Linux PC team. This is not a Lenovo presentation. I'm going to try to make it as non-Lenovo as possible. Are there any other vendors? Anybody from any of the other manufacturers in the room? That's a shame. I was hoping there'd be somebody else who could call me out if I say anything that's Lenovo specific. But yeah, my main aim is just, I'm a Linux enthusiast, and just to show what goes into making Linux work. There's a whole heap of work that comes from community, hardware vendors, all these people that we get to take advantage of. I've wanted to do this presentation for quite a few years and not had an opportunity, so I'm a little bit nervous about doing it because basically talking about what other people do. But I find it was interesting. I've been doing this job for a few years, and there's quite a lot that goes in. All right, so without further ado, oh yeah, I got into stop motion photography with my daughter, so let's dive in. All righty, so we'll start off the central processing unit, the core of the system. The good news is this is one of the best supported pieces. Kind of makes sense. You can't have a computer without it. I put 3 vendors there. I know there's RISC as well. I have no experience with RISC. I've never seen the platform, so I'm sure they will show up there at some point, but these are ones I have experience with. It's almost exclusively focused on Intel and AMD. Do have ARM laptops, but there's not really an ARM Linux program as such for desktop. I know it happens in other devices, so Intel, AMD focused. A lot of upstream work. So this is one of the things where I know in the previous talk they said timelines are short, but Intel and AMD have some amazing engineers who are getting all of the support you need for the next generation of laptop ready and getting all the drivers committed upstream. But it's really tight. It's really tight. If you follow Phoronix, you'll see patches land for Lunar Lake. And about the same time that we start having Lunar Lake samples showing up to bring up and get working. And these schedules are really tight. But they make it work. There's a lot of planning that goes into it, but they make it work. It is a challenge. So one of the big issues with this is, so patches land upstream and they take a while to go into Linus's tree and then come down into the distros. So it can be a challenge for distros that move more slowly. As Fedora fans, you're all good. Any Red Hat users, it's harder work because Red Hat do a good job too, but some of the distros will find this more challenging. And the other thing I wanted to call out, there's an increasing amount of firmware blobs. We're all open source fans because we're here. There's good points and bad points about this. We'll come to this later. One of the good things is that honestly it makes the hardware work on Linux more easily, fewer issues. Downsides as well, of course. Alrighty, so then we're going to move on for CPUs. We'll just change one letter and we'll go to GPUs. It's not an area that I know a huge amount about. On a lot of laptops, you don't need one. They have a pretty good integrated graphics unit. I should mention the CPU before does graphics. It's going to do audio. It's going to do power. It's going to do I²C. It's going to have a whole bunch integrated in that. But you might have a discrete GPU if you're a gamer or if you're doing any AI data science work. It's primarily NVIDIA. I know in the previous talk I mentioned doing work on AMD. The reality is it's a massive NVIDIA market out there right now. AMD and Intel have some really good offerings, and the good news with the Intel and the AMD ones is it's all upstream, it's in the kernel, generally works really well with Linux. NVIDIA, a bit more challenging. They've made a lot of steps forward. If anybody's been following what NVIDIA are doing, there is now an open source driver, which is amazing. It was not something a few years ago I thought we'd see. It's not upstream, it's not in Linus's tree, and they still need closed source blobs for the user space piece. But it's progress, and it's driven, honestly, by consumer demand. NVIDIA are listening, so I've got to give them credit there. And the other really good thing about the work that NVIDIA are doing is that it's really helping the Nouveau driver team, and soon to be Nova. There's a new open source driver coming called Nova. Still work to do. This does impact things like Fedora. You guys are all open source. It does mean that we really struggle delivering Fedora on workstations with an NVIDIA GPU, which is something I'll talk about in my Lenovo talk. But they're making huge progress. It's close. It's very close to being something that you as a Fedora user can put on your laptop with an NVIDIA GPU and expect it to work. And obviously, the Intel and AMD ones is going to be great. The other thing with discrete GPUs, it can honestly get really confusing. There's so much in there with the different stacks and drivers and discrete modes versus hybrid modes. It can be debugging issues there, can be hard. The other thing I'll mention, we had the AI talk, but there's two different conflicting needs. So there's a lot happening right now in the industry with data science, and that, using those GPUs for doing your data processing. And then there's the gaming side of it, where you're going to want to connect it up and play games on it, and different use cases. So different stacks, and again, more to get working and debug. I should note, I'm going to skip NPUs. I know they got mentioned in the last talk, but I don't have any experience with them yet. So I'm going to jump to Wi-Fi. That is actually a Wi-Fi chip the little penguin is pointing at. The reason I jumped to Wi-Fi is it's actually increasing importance. So does anybody here have a laptop that doesn't have Wi-Fi in it? No. OK. So Wi-Fi is really important these days. You have to have it working. And unlike the CPUs, a whole bunch of different vendors, and they all have different levels of Linux support. They have less experience, let's say. As a quick shout back, if anybody tried to buy a PC during COVID and supply chain, one of the main issues was actually Wi-Fi chips. Like, I swear we went through every single Wi-Fi vendor they sit there and go, well, we've not got enough of this vendor, so we're going to switch to this one. And it was a nightmare. And it's also primarily, I know I get a lot of complaints about why can't we have Linux at the same time as Windows? A lot of it is about getting the support for these chips upstream in time to be able to ship a device. And Wi-Fi is surprisingly often one of the blockers. I'm going to give a shout out to Intel here. Intel do a good job of getting it upstream in time. The other vendors have still some work to do. It's also an area where there's a lot of technology change, somewhat surprisingly. So last year was Wi-Fi 6E. Don't know that. It was using a new frequency spectrum and gives you faster Wi-Fi. What was interesting there is there's lots of regulatory issues. So the biggest problem was that different countries approved Wi-Fi 6E at different times, and particularly, at least for us, a lot of testing and manufacturing is done in China, and they were later for enabling it. So that made things interesting. This year, Wi-Fi 7, massively fast, 46 gig download speeds apparently. But many of the Wi-Fi 7 features are not yet ready, so we're seeing some issues around that. So it's an area there's still a lot of technical innovation happening. We're seeing, energy consumption generally is becoming increasingly important. There's lots of legislation around it to make sure that you're not shipping inefficient computers, and Wi-Fi is part of that. And we're seeing lots of issues where Wi-Fi tries to go into low power modes when it's not in use and might not necessarily come back to regular when you want to use it again. There's some challenges around that that we've seen. The other thing with Wi-Fi is it's really hard to debug. Again, you start doing packet captures, sniffers, and trying to figure out what's going on. I've had so many use cases where they can reproduce it with this access point or in this environment and not others. So Wi-Fi is much more challenging than you'd think. Alrighty, moving on to graphics and panels. I probably should have put this with GPUs, but I kind of wanted to cover Wi-Fi first. So one of the things you may notice if you look at your laptops, there are so many different panels available, which you might not be aware of. So you get the different sizes. That's fairly obvious. You might have your 13-inch up to your 17-inch laptop. Yeah, that's all good. Different resolutions. You don't see many of the 1Ks these days, but 2K, 4K. I think there's going to be 8K coming. There may be some vendors that have it. So all different resolutions, different aspect ratios. So you have all that. You'll get different refresh rates. So 10 minutes, okay, 60 hertz, and we're now seeing up to 120. All these things, touch, non-touch, and then just different display technologies, OLED versus LCD. And the other really fun thing is that generally vendors will have, there will be like 2 or 3 different vendors per panel type. It's just a massive matrix. And so the biggest issue is how you test and make sure everything works for that. I'm gonna have to start speeding up. Panel self refresh, again to the Wi-Fi with the power savings. This is a new technology. Intel had it a couple of years ago. AMD introduced it last year. It saves power by only refreshing the panel if there's a change, but it introduced issues. If anybody had a new laptop in the last 2 years, they may have hit those, and it took a while for things to stabilize upstream. I'm not going to skip that one, I don't have time. And color calibration. Vendors will sell calibrated panels, so they've been specifically calibrated if color calibration is important for your workflow. The thing that's interesting there is those calibration profiles can be used for both Windows and Linux, except for the brightness curves are different. I believe Linux has a linear brightness curve, and Windows uses a curved one. Yeah. But you can use them, but there's a whole bunch of complicated stuff tied in there with how you support it, and if you have a panel replaced, and a whole bunch of stuff around there. Alrighty, HDR I'm not going to talk about. I think some vendors have HDR systems. You're seeing it on gaming systems in particular. I don't have any experience with it. Alrighty, Ethernet. So just as I used to work on network switches, so I thought I knew Ethernet really well. It's old technology, right? It hasn't changed. Like 1 gig Ethernet, it's been around forever. It's, should all be good. The weird bit with this is that vendor support for it is really weak. I've no idea why. I genuinely have not got a clue why. They don't want to contribute upstream, and lots of issues. If anybody has Intel, vPro was a major nightmare. Like, we used to have a lot of problem convincing Intel to support vPro. That's improved. I'm going to give credit to Intel there. It's improved. But if you get an Ethernet issue and you have a vPro system, it's the ME firmware. And anyway, yeah. I'm going to skip this one because I don't have time. All right, who has Fingerprint on their laptop and uses it? Ooh, 2, 3. I thought it might be more. Alrighty, this was one of those weird ones. I was like, yeah, nobody really cares about Fingerprint. No, people who have it really like it. I use it on mine. I was like, oh, okay. It's become one of those features, surprisingly important and requested, and when it doesn't work, people get really upset. Yes. 2 different ways of doing it. There's 2 different technologies. There's match on chip, which, at least for our Linux platforms, is pretty standard. On higher end platforms, match on chip is going to be normal. And then you get match on host, where it does the fingerprint checking in software on the system. I never thought we'd get Linux support for it, but we actually do. In all fairness, the fingerprint vendors have started to do that. You might see the fprint TOD project. So there are some fingerprint chips that will start to work with that. It's kind of rare, but there's a few. There's various issues with it, and the most amusing one is, Windows has some security features, I think SDCP, so that it protects it. Linux doesn't have that, and there was a Blackwing article a year or 2 ago where they used Linux to hack the fingerprint driver to then go and reverse do stuff for Windows, and that was not good. Alrighty, this is usually a topic that's close to people's heart. I put all 3 together, power, thermal, and battery, because they're all related. They're also one of the most common source of complaints for people with a laptop. So you want to balance the desire to have superb performance, everything running as fast as possible, but I don't want my fans to run because they're really noisy, and I want my battery life to be 3 years long, and all that stuff. So it's a balancing act. It's quite hard to achieve. And honestly, we have some limitations. Linux, I think, still has a lot of work to do here, and that comes on the vendors as well. There's so many different pieces of the jigsaw. So they have all these complicated thermal tables that are used for Windows, and they do a lot of testing on that. But at least for the Intel solution, it's closed source, it's proprietary. So they've reverse engineered some of it, and we get it on Linux. But can you trust it? It's really tricky. And there's lots of things where people lots of settings they want to tweak and do things. So yeah, all that. Oh yes, the AMD have done a ton of good work here with P-state solutions. If anybody's looked at that, it's really they made a big difference. There was also, if interested, there was work on dynamic solutions. So it tries to gauge, says, oh, this guy's got workload, I'm going to give them more power, or it's idle, so I'm going to use less. It led to a lot of user satisfaction problems. So they, at least to my knowledge, that's kind of, they backed away from that. And I think this is a little bit with the Lenovo have. I think it's something which platform vendors still have some work to do. Just as a note, it's really tempting to override the defaults. I have so many people say, oh yeah, I just disabled my fans. It's like, yeah, go for it. It's really tempting. You might break your laptop. Alrighty, audio. I'm getting through this, it's good. Alrighty, so audio is another common source of problems. It's much more complicated. This is one of the areas I wish I knew my way around better, just because there's so many different layers. From the drivers all the way up to user space. You might have codecs which tell the system how it plumbs inputs to outputs with the different, you've got a headset jack or the speakers and all those pieces. You've got audio amplifiers in there. And then you've got audio firmware, the Intel SOF project, which is interesting. And then you've got, well, now pretty much pipewire, but all of these different audio layers, and if some of them don't work, it can be troublesome. I will say generally it's pretty good, but it's one of those that I find it's always more complicated than I expect it to be. If you're ever entertained, go and have a look at the kernel driver for the codec. The number of quirks in there is insane, and it's like, yeah, there's got to be a better solution for this, but I don't know what it is. But pretty much every platform has a quirk in it. Yeah, worse. So that was, it's worse than the trackpad driver. Neil thinks it's similar. The interesting one, so Intel SOF is interesting. Intel have audio firmware that does a whole bunch of the audio processing. It's open source. You can go on the project and it's all open source, which is amazing. That's great. The problem is it's signed with the Intel key, and the BIOS won't let it load unless you have the Intel sign key. So even though it's open source, if you build your own, you still can't use it, and that means if there's a problem with it, you have to wait for Intel to do a release, to then sign it, to then pull it in. So that, I know, has been a challenge for us a couple of times. Good news is it is open source, but then there's the bit that comes afterwards, but security. A quick shout out for LEDs. I'm not sure about other vendors, but I know we have LEDs on the mute keys, the microphone and the speaker. I'm assuming that's common. They don't work surprisingly often, and it's really bizarre. It's one of those, you're like, oh, why? Yes, yeah, and there's, again, complicated. More on the Intel platforms where they have these topologies that need tweaking, but yeah. And the other thing which I found interesting is the BIOS is involved surprisingly often. So, and it's one of those where you need your vendors supporting Linux, because I know we see it on the Legion platforms on our side, but the audio doesn't work and it needs a BIOS update. And you're like, well, why? It doesn't make sense. But yeah, it's annoying. And the other quick thing to shout out, again, I'm a little bit cautious because I think other vendors use different audio tuning. I know Lenovo uses Dolby, but I think there's various ones around it. But Windows gets all of this tuning done. So they have all these filter tables that make your audio sound better. We don't get any of that in Linux. So that's why if you've ever sitting there going, why does the audio on my laptop, is it nowhere near as good as Windows? Usually that's the reason. There are solutions. I think we honestly just need to do them, and there's work involved needed there.
Have you thought about reusing the tuning process that was used for the Asahi project stuff? Because that should work with Lenovo's as well.
Maybe, yeah. Sorry, that was a question if we wanted to reuse the tuning stuff doing Asahi. So I should probably talk to you after I looked at it when it was first done. I've got 5 minutes left. So we'll talk about it afterwards. I'm going to be really short on question time. I will happily talk to anybody afterwards. All right, I might skip WWAN. Anybody here uses WWAN? Yes? It's popular in Europe, less so in North America. You do? Okay. WWAN is insane, but it's becoming increasingly important, especially as 5G networks become more ubiquitous and cheaper. there is just a ton of regulatory work, and modem experience are really, again, shout out to Quectel there, but there's a lot of work happening upstream. If you were old school using a USB modem, you could hack it. They're now PCIe. It's basically not possible. I do want to just do a quick shout. I put packaging nightmare just because this is one of the areas where there's a closed source piece. We have all these regulatory requirements, so we have a closed piece of software to unlock your modem. We have no choice about it. I know another vendor suffers from this, which is why I felt comfortable putting it in here. But it means for something like Fedora, it's really hard to get this working. We block WWAN on our Fedora preloads. I don't know what other vendors do. The other thing that's interesting is eSIM is becoming a requirement. US carriers are requiring eSIM as part of their certification process that we have to do if we want to sell a system with WWAN support on. So if you're interested in this, come talk to me. I can talk about this for a lot longer, but I'm going to run out of time. Camera. Well, camera generally works really well. If you have a standard USB camera, it's good. Pro tip, if you're buying a laptop, avoid the RGB plus infrared. The infrared is used for Windows Hello to do the face recognition. And I know we have Howdy. I've had mixed experience with it, but unless you're going to use that face recognition stuff, if you buy just the RGB, you'll have a better camera experience. They have to oversaturate the image for the IR to work. There is also the MIPI camera. We call it computer vision. I'm not sure what other vendors call it, but there is still a lot of work to go on this. I've been talking to Intel for probably 3 years on this one now. So avoid it. Linux support is coming. It is, and it's stepped forward a lot from where it was previously. There's Hans de Good on the Red Hat side who has been doing a lot of work on that, but it's not there yet. The good news is, I was really worried about this because it's closed source piece for the image processing, but there's work being done in libcamera to do an open source solution. It's not there yet. Tried it last time I tried it. It's like very saturated images, but it's coming. I don't know how long it's going to be, but yeah. For now, if you can, avoid it. All right, we're almost near the end. Memory and storage. This is rarely a problem. I figured I needed to put in something positive. I know there's a new memory standard, LPCAMM 2, which is supposed to, anybody, who here loves soldered on RAM? Everybody, yeah, right? So this is supposed to mean that vendors will get away from soldered RAM. Fingers crossed, fingers crossed. So I know we have it on one platform, and I'm sure other vendors do on theirs. And it just worked. It was not an issue, which was nice. We do see SSD issues on Linux, and the amusing reason is because the Linux driver is faster. So we have a few cases where uncovered really, corner cases in the SSD firmware. 2 minutes, I'm doing all right. Right, this is the stuff I cut out. I'm going to do a very quick shout out, paperwork and regulatory, because there's a lot in there. But yeah, there's all this other stuff, but I only have 25 minutes. Alrighty, thank you. Any questions in my 2 minutes? 1 minute?
Okay, we have one.
And please do come and find me afterwards. I realized I was very tight on this and didn't really give any opportunity.
How committed are you guys to supporting Fedora? Because the only other computer made in the United States or in North America or China or anywhere is the System 76 company, and they only support one distro.
There's lots of vendors doing Linux support now. It's really exciting to see.
Yeah.
This is without my Linux. I'm so happy. I'm going to say it's hard work, that regulatory piece. It's not obvious, and any vendor who is doing a Linux preload deserves credit because it's not. But no, Dell does it. Tuxedo, Slimbook. There's a ton of them, and yeah, it's good.
It's not a question, but more a comment. Is come to Joseph Gayoso's Fedora marketing talk this afternoon, and you'll hear about the work that we've been doing together with folks like Mark on Fedora Ready, which is our program that we're launching to better identify those laptop models that have good Fedora Linux support out of the box, including the laptops that Lenovo ships. They have that lenovo.com/Linux page, super helpful. But do come to Joseph's talk. You'll hear more about it from him.
No, and the Fedora marketing team has been doing great. I'm going to say, doing a preload, there's lots of energy certification, and there's lots of There's lots of laws that you have to meet if you're actually selling something and supporting it. So it's not easy. Alrighty, have I hit it?
You still have, out of time.
Hey, last stop motion animation. And just saying, the penguin was made by my daughter. I said, I need a penguin. I got a penguin.
All right, thank you.
Thank you.